What's happening, dogs? Mr. Allen here with some dope application of exponential and logarithmic functions. It's going to be, dare I say it, exponentially fun. All right, we got Drake bought a boat for $260K. Its value is decreasing continuously at an annual rate of 5.7%. What is its value after 5 years, and when will it be worth $125K? All right. So big thing here is that it's decreasing continuously at an annual rate. Now, although we see annual here, continuously tells us it's going to be a particular formula, right? We're going to have an annual rate regardless of how it's, compounding. All right, so continuously. That's an A PERT formula, or sometimes people write it, so we got A of T equals P e to the RT, or sometimes you'll see it as N of T equals N naught e to the RT. Each one is the same. P or N naught, that's your initial value. E is just E, right? R is your rate and T is your time. So let's go ahead and write up a beautiful, wonderful, fantastic formula for this one. So I'm going to use A of T, all right? The amount of money that it's worth after a certain amount of time. I like that. It's lovely. We got $260K, so $260,000 E to the R. Now it's decreasing, so it's going to be a negative 0.057. We got to move that decimal 2 places. It's going to be negative 0.057, and we don't know our time. Well, we do know it for the first example, but we got ourselves a nice little equation here, right? So now I have A of 5, so 5 years. We got 260,000, 1, 2, 3, e to the negative 0.057, 7 times, and then we've got ourselves 5 years, right? 5. Beautiful. Excellent. Fantastic. Well, I can't do this in my head. I don't know about you guys. So I'm going to bust out that TI, you know what I'm saying? All right. So we got 260, 260, 000. And then we got E, which is second ln. It's right next to that 4 there. All right. And then I got negative 0.057 times, and we have 5 years. Hit enter. This guy's going to be worth $195K, right? About $195,000. So 195, comma 523 point, we'll go down to the cent, right? 71. Now, if we said to the nearest $1,000, right? We want you to round to the nearest 1,000. This 5 would get rounded to a 6, so 196,000 would be the answer for rounding to the nearest 1,000. Okay, so sometimes we'll ask different questions like that. But there we go. There's our value after 5 years. Now, we also ask, what is it going to be, or when is it going to be worth $125,000? That sounds like we're solving for time. I've never done that before. Or have I? Oh, all right. So let's see here. When is it going to be worth $125,000? That's my amount of money after a certain amount of time. So why don't I say 125,000, okay, is equal to my right-hand side of the formula. 260,000 e to the negative 0.057t. Now, we could do one of two. We got a couple things here. We could solve this thing graphically, right? I could plug this in for y1, that in for y2. I'm going to have to adjust that window quite a bit. All right, but we can do that. You know what? Let's do that first. Let's do that one. Let's do that way. Let's see. Well, I'll give you the choice as to what you like most. So if I plug this in, I got 260,000. There we go. Second E raised to the negative 0.057 times x. And then I'm going to have 125. 1, 2, 3. All right. Now, when I'm going to change my window, here's what we're going to do. We're going to be strategic about it. If I want to see this whole graph, okay. Now, x is our number of years, right? X is t. T is our number of years. I'm just going to go like 30 years. That seems reasonable, right? Who knows how long it's going to be? If we need to go a little further, we can. Now, my y max, I want to see all of this, right? So I got to be at least 260,000. Let's go 275. 260 would be fine, but I'm just going to go a little bit above because I like to see what's going on. You know what I'm saying? All right, hit enter. Boom. Look at that. We can see that intersection. Now, how do I solve this? Second calc. All right, we got to get our intersection. So number 5 there. I'm going to hit enter on the blue, enter on the red, enter again to guess. And there we go. We got 12.84856. I'm going to jot that down up here in green. Okay, so we got 12.84. Yeah, 12.85 years, right? Okay. So that's what we have for our graph. Now, I'm going to show you guys how to also solve this thing algebraically because you might like that a little bit better, okay? So I can get this t here by dividing, by 260,000. So 260,000 on both sides. Okay. One more. There we go. All right. And then I'm going to have whatever this number is right here equal to, so let's actually, well, let's see here. We'll leave that. Let's go with 125 over 260, right? I can cancel out all those zeros. That's pretty dope. All right, equals, then we got e to the negative 0.057t. So now what I have here is I have an exponent, right? I got to get to. It's e. Natural log is log base e. I can rewrite this in log form. Okay, so we can either loop and swoop, and we'll have log base e of this fraction here, 125 over 260, equals this negative 0.057t. And then my last algebraic step here is dividing by that negative 0.057 on both sides. Negative 0.057. That's going to give me t. So that looks terrifying, right? That looks absolutely awful. Not fun at all. Now, log base e, that's just natural log. So really what I got to type in my calculator here is natural log of that 125 over 260, all divided by negative 0.057. I have a feeling that some of you are like, bro, I'm going to go ahead and graph that thing, right? It gets a little ugly. But sometimes that window, when we don't have context, it's hard to adjust that window. So natural log of, and I'm going to hit alpha x to get a fraction here, 125 over 260, right? Close that. Oh boy, I didn't remember to put a fraction. I think I can do this if I hit alpha x. Ooh, yes. Yes. All right, and then I got negative 0.057. Hit enter. Oh my goodness. We just got the same exact answer right there. We did it algebraically. We did it graphically. We're like a Swiss Army knife of math over here, all up in this problem. That's dope. That's awesome. Hope you guys enjoyed. I enjoyed thoroughly. It was exponentially fun indeed. See you later.